Hello, this is Mr. Huber. In this lesson, we're going to learn about the order of operations, which is very important so that people everywhere are doing calculations in the same order, in the same way, and we have consistency in the answers we'd be getting from problems so that people aren't getting different numbers, different answers, because they're just doing them in whatever order they want. Okay, the order of operations here gives us a way to do these problems by looking for grouping symbols first. Okay, grouping symbols are most typically parentheses, but they can be brackets. They could even include absolute value bars, which we'll see as well. Then we have exponents. So after we find our grouping symbols within there, we follow this order to do our calculations. Exponents is our first calculation. Then multiplication and division, then addition and subtraction, and then we'll see when there's a fraction bar that actually groups things by a numerator and denominator separately from each other, then we handle the fraction bar as our last step. Also keep in mind, for multiplication, division, and addition and subtraction, we want to work from left to right. So we don't always multiply and then divide. For instance, if we had 45 divided by 5 times 9, we do the division, then the multiplication. All right, let's talk about a way that we can help remember that order for these operations maybe a little easily. Some of you may be familiar with this and heard this, PEMDAS. PEMDAS is an acronym, the P for parentheses. That's our most common grouping symbol, but keep in mind, this could mean any type of grouping symbol. It doesn't have to be parentheses. Then we'd see our exponents, then multiplication and division, then addition and subtraction. And keep in mind, we go P parentheses, any grouping symbols, then we handle our exponents, then MD. The M doesn't always come before D. We have to go from left to right for multiplication and division. They're grouped together. And then same for addition and subtraction. All right, let's see some examples here of some problems we can work out these order of operations in. And as we go through, you're going to write down each step. Every time you do one calculation, write down the whole problem again after evaluating that one step in the order of operations, and then look again at what's next in my order. So for this first problem, we're going to see that we have 27 divided by 3 to the second power times 2 minus 3. There's no P parentheses, any type of grouping symbols, but we do have an exponent, so E, exponent. So we're going to handle that part first. This right here is going to be our first step, 3 to the second power. So we're going to have equals 27 divided by 3 to the second power is 9 times 2 minus 3. So now that we've done that step, we've written it down. Now take a step back, look and say, what would I do next? Okay, there's no grouping symbols, there's no exponents, so I have my MD. But remember, we don't always do M before D. Left to right, division will actually come first here. So we're going to do 27 divided by 9, which is 3 times 2 minus 3. That equals 3 times 2, which is 6 minus 3 equals 3. And that's our final answer. In this next problem, our grouping symbols, we have some. So P, parentheses, right, doesn't have to be, but we have them here. Parentheses. Inside there, we're going to follow our order of operations. So we're going to do the 3 squared as our first step. So this is going to equal 24 minus 9 plus 1. That's 24 minus, we stay inside the grouping symbols and evaluate everything in there first. And now we come back out and we say 24 minus 10 as we take a step back. That's our only calculation left. That gives us 14. In this next problem, something to keep in mind, we have parentheses and then another set of parentheses outside that. Sometimes we can write that as brackets. So sometimes we might see brackets for those outer parentheses. Okay, don't have to. It's the same thing, just something to keep in mind. That's another type of grouping symbol. Just help distinguish it so we don't get confused by multiple sets of parentheses. In this case, inside that big set of parentheses, or in this case would be inside the brackets, we're going to follow our order of operations, do what's in the innermost parentheses first. Okay, so this is going to be 2, and then 9 plus 3 is 12 divided by 4. So now we're going to do 2, and then 12 divided by 4 is 3. And when we have a number next to parentheses here, that's the same as a multiplication symbol, so 2 times 3, that equals 6. All right, so keep in mind, each step as I wrote those down, step back, said what's next in my order of operations, make sure I'm following and not jumping around, and just calculate one step at a time. Here we can use the order of operations to evaluate. Right? We're going to substitute an 8 in for y, and then go from there. So first thing I'm going to do is rewrite this with an 8 in place of the y. Now I can look and say, what do I do for my order of operations? There's no grouping symbols, but I do have an exponent. So I have negative 8 squared is 64 minus 3. Negative 60 more minus 3 is negative 67. One thing to keep in mind, negative 8 squared is different than negative 8 with parentheses squared. Right? Here, the negative is not being affected by the squared. We're just squaring the 8. 8 squared is 64. The negative sign just stays as it is. Here, we're doing negative 8 times negative 8. That would be a positive 64, and this is a negative 64. So those parentheses make a difference. When you're squaring everything inside the parentheses on that second way we've written it. So just something to keep in mind so you're not making mistakes with signs on those numbers. In this next example, we're going to have 12 minus 8 plus 1. Following order of operations, we're going to subtract and get 4 plus 1, which would be 5. Right? So working from left to right, we subtracted then added. If we had added first, if we always did addition before subtraction, we'd have 8 plus 1 is 9, and we do 12 minus 9, we get 3. It'd be a different answer. That's why we have an order of operations so that everybody who's doing a math problem is following consistently the same method, and we're going to all get the same answer. In this next example, we're going to plug in an 8 for the y, and now we're going to see that fraction bar come into play in our last step. So first, the numerator and the denominator are grouped separately. This fraction bar is grouping the numerator with the denominator. So in the grouping that is the numerator, we're going to follow our order of operations, do 10 times 8 and then plus 1. So we're going to have 10 times 8 is 80 plus 1 over in our denominator. Only one calculation to do there, so plus. Now we have 80 plus 1 is 81 over 9. And then our fraction bar is our last step. So remember that order of operations, we've calculated everything in the numerator, in the denominator. And at the end, we're going to use the fraction bar to evaluate this. 81 divided by 9, right? A fraction is numerator divided by denominator, so that equals 9. Right, moving here to an application of this. All right, here in this problem, we've got John making copies of a science report. He's going to have black and white pages and color pages, and he's going to pay a copy center to do the work of making the copies and putting these together for him. Right? So he's got a cost to do that. His cost is written here, where we've defined the variables. C is the cost of a color page, B is the cost of black and white page. You could use X and Y, you could use M and N, you could use any letters you want, define them. So C for color page, B for black and white page. So we know what the letters are representing in this expression. And he's going to have 5 color pages and 20 black and white pages. So that's why the color pages are times 5, the black and white pages are times 20. And then the 4 here is because he's making 4 copies. So this cost to make 1 copy, we're going to have to multiply by 4 to get the total cost. And we can evaluate this now substituting the values in that were given for the cost for the color page, which is $1.50. So we're going to have 4, in parentheses 5 times $1.50 plus 20 times 0.05. Right? We can evaluate this now using the order of operation. We're going to have 4, and then we have 750, 5 times $1.50 plus 20 times 0.05, 5 cents for each one of those is 1. So that equals 4 times 8.50, okay, which is $34 for a total cost. So we've got that expression. We can substitute values in for the variables, just like we did in the problems before. We do y equaled 8. Now if we know c equals 1.5, we put a 1.5 in for c. We know b equals 0.05, we put a 0.05 in for b, and follow our order of operations to get our final calculation here of $34. As we move ahead, before we get to a little math, well, I guess there's a little math here. We're going to try and do a little estimation. Worth its weight in, normally we say gold, but here bacon. How much bacon do you think comes from a 250-pound pig? If you give that a thought as we look ahead to a cross section here of a pig and showing you where different cuts of meat come from on that, you're probably familiar with pulled pork, right? That comes from this part right here. They call it the pork butt commonly, but it's really the shoulder. So if you hear someone talking about pork butt, pulled pork, it's pork shoulder. It's where it actually comes from, the pig. Bacon here is pork belly. Okay, and depending on how you cut it and cure it, it's going to be a little different, but you're going to get about 16 to 20 pounds of bacon from a 250-pound pig. So 16 to 20 pounds, which is a pretty good amount. I don't think I could or should eat all of that, but maybe for the course of several days or weeks. All right, here let's look at some more evaluating expressions. Follow the order of operations. Again, you should be trying some of these as well on your own and seeing if you're getting the hang of it as we go along. So we're going to have 4, and then 5 minus 3, because that's in parentheses, and then minus 1/2. 6 minus 16 is negative 10. That's going to give us 8, and we have a negative times a negative, so plus 5. 1/2 times 10 is 5. Negative 1/2 times negative 10, and negative times a negative plus 5, so we're going to get a final answer of 13. All right, in this next problem, get numerator and denominator grouped separately. So let's look at the numerator. Our first step is going to be the 5 times 2. That's our multiplication, plus 48 divided by 12 over 2. And now in the numerator, don't do the 10 plus 48 because the division will come before the addition. So we're going to have 10 plus 4 over 2, which equals 14 over 2, which is 7. Right? Our last step is that fraction bar. And let's see a couple evaluating. We're going to substitute the values of the variables in place of those letters and do our calculations from there. So we're going to have 6 times 2 minus absolute value. So we're going to see that coming into play here. 3 minus 11 plus 3 to the third. So absolute value bars are a grouping symbol. So we're going to do our calculations that are inside there first. So we're going to have 6 times 2 minus negative 8 plus 3 to the third. That's going to be 6 times 2 minus 8. Absolute value means the positive value of that number. Don't just change signs. It's the positive value of what's inside those bars. And then plus 3 to the third. So we've evaluated our grouping symbol part, right? The P in PEMDAS, if you will. Okay, it's not parentheses, but it's a grouping symbol. Now we can go back to the rest of our order of operations, and we're going to find that our next step is to do the exponents. We have 6 times 2 minus 8 plus 27. Or 3 to the third is 3 times 3 times 3. 3 times itself 3 times. This is going to equal 6 times 2 is 12 minus 8 plus 27. 12 minus 8 is 4 plus 27, which equals 31. Right? The subtraction comes before the addition there. And now here in the next problem, we're going to have 3 times 2, parentheses, r plus r. Okay, so fill in both r's as 3's. That's great. Squared minus 2. We don't just write one 3 in there. Fill in everything, write it exactly as it is, but with numbers in place of the variables. So we're going to have 3 times 2, 6 squared minus 2. Now we want to be careful here. Your next step is your exponents. We've done everything inside the grouping symbol. So this is 3 times 2 times 6 squared. So the exponent will come next. That's going to be 3 times 2 times 36 minus 2. So next is going to be the 3 times 2. So 3 times 2, which is 6 times 36 minus 2. That's 216 minus 2, which is 214. All right, so we've seen several examples here of the order of operations. It's important just to slow yourself down, take a step back after each step, one at a time. Find your grouping symbols, evaluate inside there. Then as you work through exponents, multiplication, division from left to right, addition and subtraction from left to right, and if you have a fraction bar at the end, you handle that last. So you get more used to this, you get a little more comfortable with it, but it's really important. So again, we can all be getting the same calculations, the same consistent answers by doing the order of operations the same for everybody.